Check whether functions u, v, w are functionally related and find their relation. We will have to evaluate this Jacobian, and if we obtain this Jacobian takes the value 0, then we will conclude that u, v, w are functionally related. We have the Jacobian is the determinant whose first row is first order partial derivatives of u with respect to variables x, y and z. We have dou u by dou x equals e raised to y into sin z, and dou u by dou y equals x e raised to y into sin z, because derivative of e raised to y is e raised to y itself, and dou u by dou z equals x e raised to y into cos z, because derivative of sin z is cos z. Now we will write the second row, which is obtained by taking first order partial derivatives of v with respect to variables x, y and z. We have dou v by dou x equals e raised to y cos z, dou v by dou y equals x e raised to y cos z, and dou v by dou z equals negative x e raised to y sin z, because derivative of cos z equals negative sin z. Third row of the determinant is obtained as the first order partial derivatives of w with respect to variables x, y, z. We have dou w by dou x equals 2x e raised to 2y, looking at the expression of w, and dou w by dou y equals x square e raised to 2y multiplied to 2, and w is independent of z, therefore dou w by dou z equals 0. Now we will expand this determinant, and we see that determinant takes the value 0. We will expand the determinant by usual expansion along the first row. We have e raised to y into sin z multiplied to these two values multiplied minus these two values multiplied minus this term multiplied to these two values multiplied minus these two values multiplied, and this expression multiplied to these two values multiplied minus these two values multiplied. Whenever e raised to 2y gets multiplied to e raised to y, it becomes e raised to 2y plus y, which becomes e raised to 3y. So wherever we have e raised to y multiplied to e raised to 2y, it is rewritten as e raised to 3y. You notice that these two terms are exactly the same, and these terms are also same, and hence we have determinant value becoming 0, which establishes functional dependence between functions u, v and w. When you square and add functions u and v, you see that u square plus v square equals x square into e raised to 2y multiplied to sin square z plus cos square z. Since sin square z plus cos square z equals 1, we obtain u square plus v square equals x square e raised to 2y, and thus we have u square plus v square equals w, which is the required relation.